Hopefully this video is going to be able to help you work with the moment of inertia problems for part 2 that I have posted. The basic formulas that you are going to need to calculate in this activity are going to be the following. You will need to understand that I sub c, which is the moment of inertia with respect to a specific axis of just the shape without regards to the shape's distance from the referenced axis. So the I sub c is what we talked about yesterday. It is the moment of inertia for just the shape, and I sub c equals the base times the height cubed divided by 12. The other formula that you will be using that we talked about in today's lecture is the moment of inertia, and that is just I, not I sub c, with respect to a specific axis. So that is going to be the moment of inertia of the shape, which we calculated here, plus d squared, which we will talk about in a couple of minutes, times a. So if you don't have those written down from class, or what you need to do is write those two formulas down now. Those are the two formulas that we will be using throughout the course of this exercise. I'll give you a second. You can always pause the video, so I'm going to assume you have that, and I'm going to erase those now, but we will be using those. All right. Now, in the first couple of exercises that you see, you're just going to be given a basic rectangular shape, and we're going to have to calculate the moment of inertia for that shape and look at the shape's moment of inertia with respect to an axis. So here I have a 5 by 6 rectangle that is 3 away from my y-axis, and it is 1.5 away from the z-axis. You will notice on the problem that the actual I sub c value is given. I am still going to calculate it here so that we can understand the problem in its entirety. The problem, when you look, it will have a specific axis that you are working with. In this problem, we are looking for I sub z. So the information that we have here, though it's still going to be there, this information is not going to be relevant to the rest of the problem. So we can just ignore that information as we look for the value with respect to z. So here's how we find the I sub c of just the shape. Since we are going with z, we know that the base value is 5. So our I sub c equals base times height cubed over 12. So in this case, I sub c is going to be 5 times 6 cubed over 12. And we see that the I sub c value is 62.5. So I sub c equals 62.5. The other question that the next thing we need to know is the distance. So the distance is the distance of the centroid of the figure to the axis that we are looking for. So in this case, we find the centroid. Now remember, we're just talking about this z-axis, right? So this is our, the z-axis. So this is the axis that we are concerned with. We know that the centroid of the shape is going to be at 2.5 into the shape. So the 2.5 plus the 1.5, the distance from the centroid down to the z-axis, the distance from the centroid down to the z-axis, d equals 4. So now we have calculated the 62.5 and the 4. So that is the information that I need. I'm going to go ahead and get rid of all this. Now I'm going to go to my other formula. Sorry, it keeps blurring out on me. Hopefully it'll pop back in. Come on. I don't know why it got blurry on us all of a sudden. Let me move the camera a little bit. Yeah, knucklehead thing. I'm going to pause it. And we're back. Alright, so I'm going to take that information. Now I've got that other formula that we wrote down earlier, that I equals I sub c plus d squared a. So we now know our I sub c is 62.5 plus the d value is 4, so we have 4 squared. The rectangle that we're working for was 6 by 5, so the area of that rectangle is 30. We take the 62.5 plus the 16 times 30, and our overall answer is 542.5. So that is how you calculate the answers on the moments of inertia part 2, number 1, 2, 3, 4. So that should get you through 4. It should, and then I'll do another video for the next part. So that is moment of inertia 1 through 4.